Okay, so you guys remember from chapter 4, we talked about rates and proportions and the constant of proportionality, which was just meaning it's a constant rate. For example, if you buy a pack of batteries, how many is one battery, right? That's the proportional relationship. 4 batteries for $4. Well, how much does one battery cost? Well, that's easy. It's $1. And rates are a very important thing because often we think of rates as just not being fractions or proportions, but that's what every rate is. When you say you're going, uh, you know, 70 miles an hour on the freeway, that's a rate, but it's actually also a proportion and a fractional mathematical value. And that's what we're going to go over today. We're going to see how what you did in chapter 4 is going to relate to what we're doing now in chapter 7. So let's go over a little review. And we'll talk about rates. And let's imagine that, let's talk about some chores. Let's imagine your mom wants you to do some chores. Okay? And I'm going to make a little graph here. Let's say your mom, and I had chores like filling the swimming pool with water, which I go make a sandwich, and then the swimming pool would overflow, and we lived on a hill, and the water would flow down and ruin the plants of the person that lived down the street. And then one time, my dad was like, "You need to put all the chemicals in the pool." And I was 7 years old, and he's like, "That's your chore. I'm gonna pay you to do that." I'm like, "Okay." I have no idea what I'm doing, and so I just threw all the chemicals in the pool. And then all my friends jumped in, and then my brother was like, his eyes were like, I was like bleeding from the eyes, and everyone's like, "What did you do?" I was like, "I put the chemicals in the pool." And they said, "Well, how much did you put?" I said, "All of it. I don't know what I'm doing. How would I know?" Apparently, there's a pH to the pool. I didn't even know what that was. Anyways, we're talking about chores. Okay, let's say your mom is going to pay you, I don't know, $30 for 6 hours a week. This is the summer. It's a day during the summer. She wants you to do something. She's like, "I'm going to pay you $30 for 6 hours of work." And you say to yourself, "Okay, well, let me graph this out." So let's say, I don't know, I didn't want to do that. Let's do, I don't know, 5, 10, 15, 20, 25, 30. Here's 30. Here's 1, 2, 3, 4, 5, 6. Here's 6 hours of work. And you're right here. And you're thinking, is this a good wage? Am I making a good amount per hour? What am I making per hour? And some of you are going, "Well, that's easy. I know what that is. I'm just going to divide it by the number of hours." Okay, sure. And so here, you've got your money, you've got hours. So what is the money per hour? And if you've noticed, it's like a division problem. Well, it's just $30 per 6 hours. And again, you're thinking, "Well, Mr. Rabin, I already know this. This is easy. It's just 30 divided by 6. It's $5 an hour." But of course, that's not the important part. The important part is I want you to understand the actual proportional relationship, how it's written, and when you say something, I want you to think the math and how to write an equation. So, dollars per hour. That's what we just did. We did $30 for every 6 hours. And if you remember this, we did this before in chapter 4. Okay. Let's $30 for 6 hours. Well, how much do I get per hour? Well, it's 30 divided by 6. You're just reducing this fraction. This is a fraction right here. If I reduce this fraction, I divide the top and the bottom by 6. That's essentially what I'm doing. Divide by 6, divided by 6. And what do I get? I get 5 over 1. $5 for every 1 hour. That's like $5 an hour. So when we say $5 an hour, that's what it means. So that's $5 per hour. So let's say we wanted to create an equation. Okay? And it's an equation for a wage. Let's call W for wage. W for wage. What does W equal? Well, isn't this is our wage right here. So W equals what? The amount of money we make over the hours worked. So we could call this just M for money. Or you know what? We don't have to do that. We'll just do this. This is our equation. H for hours. So W would equal our money symbol over H. Just like that. There's an equation. We just made an equation. So if I said you're going to make $100 over in 5 hours of work, what's your wage? Well, my wage would be $100 for 5 hours of work. What's the ratio? $20 per 1 hour of work. It's just 100 divided by 5. Or just 20. $20 an hour. So I want you to think of things in terms of a rate and how to make an equation. So given this understanding, let's try a different example. Maybe something you haven't seen before. And we will create a new whiteboard. That one's not moving. Windows is always funky. Okay. So, let's imagine a situation. Oh, what did I read about today? Oh, that's right. Let's say here's a little car. There's a little car. It's a futuristic car. There's a person basically standing while driving. I'm a bad driver. And let's say that this is Angelina. And you got over here, oh, I don't know. Here's Brad. And here is, and they're holding hands. That's Jennifer. So here's Angelina Jolie, Brad Pitt, Jennifer Aniston. And she's driving really fast. She's mad because she's crazy. She's just crazy. Jennifer Aniston, very nice person. Makes sense. They belong together. But Angelina, oh, she's crazy. She's driving really fast. And let's say that she's in Hollywood. But Bradifer's on vacation in Las Vegas. They went to Vegas. They want to see Penn and Teller, little magic show. Okay, and let's say the distance between them is, I don't know, 200 miles. Okay? And let's say, I don't know, let's say that Angie knows that it will take her 4 hours to get to Vegas. Okay, at a constant speed, she's driving at a constant speed. She's driving real fast because she's crazy. And she knows it's going to take her 4 hours. 4 hours to get to Vegas. And she has to travel 200 miles. Well, let's create a graph, shall we? Let's create a graph. Oh, you know what? I want you guys to see this, so I might have to move the graph over. Let's create it right here. Okay. And I'm going to put distance here. I'm going to put time is here. Because that's what we have. We have a distance of 200 miles, so it's in miles. And the time is in hours. So we'll say hours. And of course, you might say, well, why put time on the bottom? Well, you're going to see when you do math, it just kind of makes sense. Like, think about over time. Someone grows up, they get a little bit bigger, then they get a little bit bigger, and then they get an adult size, right? Left to right. It just makes sense. If you can do it the other way, but then you're just going to confuse yourself. The graph will look weird. We read graphs from left to right. You know, here's 0, and this is the positive direction. It just makes sense to do graphs that way. If that's what you're thinking. I don't know what you're thinking. I can't. I'm just recording this. Okay. Well, what did we do before? We know that, let's say that, I don't know, let's say this is 20, 40, 60, 80, 100, 20, 40, 60, 80, 200. So here's 200 miles, and here's 1, 2, 3, 4, 5, 6. 6. Maybe I'll write time down here so you can see it. Time in hours, not 2 S's, 1 S. See, I can just go back and then go, I corrected myself. And here is 6. So that's 6 hours. We'll zoom on that just for a second, just so you can definitely see that. Okay. So we have 6 hours. So, well, let's look at that in terms of our rate, like we did just in the other example. Well, she went 200. So how far did she go? Miles. Let's write a proportion. Miles per hour. Well, she did 200, or she will go 200 miles. In how many hours? 6. 6 hours. So now we have a rate here. She will travel 200 miles in 6 hours. Well, that begs the question, what would be the rate? Because this is a rate here. This is her rate. How far can she travel in 1 hour? Well, aren't we just reducing this? Oh, wait a second. Did I say 4 hours before? Does it matter? Yeah, we'll just do 4. I said 4. My mistake. Already forgot. 4 hours. 1, 2, 3, 4. There we go. And let's correct that. 200 in 4 hours. I could have just done 6. Doesn't really matter. Okay. You're probably going, Mr. Raven, what are you doing? Okay. She went 200 miles in 4 hours. How fast? Ooh, I've kind of gone a little ahead of myself there. How far can she travel in 1 hour? Well, let's just reduce that. 20 divided by 4. I want to make it easy for you. What's 200 over 4? Anyone? Anyone? 200 by 4? 50. It's just reducing this. We're just dividing. Remember, when we reduce a fraction, we're just dividing both sides by the largest number. That would just be 4. And that is 50 over 1. So she's going to travel 50 miles in 1 hour. Well, what's another way of saying that? 50 miles per hour. This is something that we all see and all know, but that's exactly what it means. 50 miles per hour. 50 miles in 1 hour. So that's the same as 50 miles per 1 hour. That's what it's saying. It's the same thing. So we just figured out how fast she was going by making a rate. And what is our rate? Can we make an equation so that we can do this with anything? Let's make an equation. So this is the rate. So in green pen here, I'm just going to say rate equals, and what is this? What is this? Miles over hour. Well, we could say miles an hour, but what if we made it general for any type? Maybe we're going kilometers per hour or meters per second. You often hear that. Or the 50-yard dash. How far do they go in 50 yards? 4 seconds? I don't know. So this is distance. It's just miles is the distance. So we're making it very general. Distance over what? Well, hours, that's just the time. Time. And we can abbreviate these. We can say R for rate. We can say D for distance and T for time. And so it becomes a formula. Let me go over a little bit there. Okay. Where you see R equals D over T. It's something that you're just going to be seeing always in math. And you're going to see that you can manipulate these around too. And we kind of did it the other day. I kind of like briefly showed you how we could manipulate them. But now we've got a formula. So let's use this right now. We've got a formula to find the rate. Now rate equals distance divided by time. So it's just how fast we're going. Our speed equals the distance divided by the time. Uh-oh, what happened there? Let's Control Z that. There we go. Okay. So, on your homework, there is a few questions on distance, rate, and time. And this is the first one. You'll see that this is the first one. I have a Google Doc. I'll be uploading it tonight. Maybe I already did. I'm not really sure. And the first question is this right here. So, taking what we know that the rate equals distance over time. Knowing what we know, let's read this question. An airplane flies with a constant speed of 300 miles per hour. How long will it take to travel a distance of 6,000 miles? Well, let's color code this, shall we? Let's say rate equals distance over time. So what's the rate? Well, the rate is right here. That's the rate. And how about the next part? What was the question asking? How long will it take to travel a distance of 6,000 miles? So what are they asking for? Well, they're asking for this guy right here. They're asking for the time. So we're given a rate and we're given a distance. That's this guy right here. So essentially, we're just solving for one variable. So we know the rate, that's 300 equals, what's the distance? 6,000 over t, the time. And so we're just solving for t. And if you notice, this is very similar to what we just did the other day, where you have the variable on the bottom, and you need to get the variable, you get t up here and solve by itself. It doesn't matter what side you do it. It doesn't matter how you solve it. We just want t by itself. So we need to get t by itself. I'm going to move this up. And some of you, you're like, oh, Mr. Raven, this is easy. I can do this. Well, how do we do this? How do I do this? I want to get t by itself. Well, there's other ways. You could. Some might say, well, what if I divide by 6,000 to get 6,000? But then you'd have a 1 over t. What if I multiply both sides by t? This is just a fraction. I have a t on the bottom, a t on the top. Well, that's just something over itself is just 1. They cancel. And then I have t times 300 equals 6,000. And that might look weird to you. T times 300. Can I write that the other way? Does it matter which side the t is on? What if I just rewrite that? It makes sense. Maybe you're more comfortable with that. 300t. Doesn't matter. It's the same thing. Can I solve that now? Yeah. That's easy. Just divide both sides by 300. Divide both sides by 300. The 300s cancel. I've got t equals 6,000 over 300. Do you know the trick? Just cancel out the zeros over each other. It's just 60 over 3 is 20. And what are the units? 20 is just not an acceptable answer by itself. What are the units? Stop that. Control Z. Control Z. Okay. The units are how long will it take to travel a distance of 600 miles? 300 miles per hour. So what is t? What is t? Sorry, forgot to write the zero. What is t? T is hours. That's our unit, is hours. Now, some of you may be thinking, is there a better way to do this? There is. And we talked about manipulating this equation. So let's go off to the side a little bit here. I know that r equals d over t. Well, I can manipulate this equation to get t equals d over r, and d equals r times t. Before I even solve one of these equations, if I know what I'm solving for, I can make it easy. And how did I get these other equations? Well, I just used algebra. Remember, I kind of alluded to this in the last class, and what did we just do in the other equation? We multiply both sides by t, and what happens to this t? That disappears. They go away, that's 1, and I've got t times r equals d. Now, if I write this the reverse way, if I go t equals rt, this is the equation that I like to remember. Why? Dirt. kind of spells dirt. I just think of dirt. D equals RT, dirt. If I remember that, I always know that D equals RT. I don't even need to think about it. I don't have to go through all the things to create the equation. I just remember this one, because then I can manipulate it. If I know that D equals, and I'll zoom in. If I know, ooh, let's go crazy. Okay, D equals RT, I can manipulate that to get anything I want. What if I'm solving for T? Okay, I want to get T by itself. Okay, how about I divide both sides by R? What happens to the R? They cancel. Now D over R equals T. And of course, it's always weird sometimes when you can just say, hey, how about just T? And I erase this. Same thing on that side. So I can solve it any way I want. Because if I started with this equation here, D equals RT, and I'm just going to erase all of this and show you real quick before we end how D equals RT is actually quicker. I have D equals RT, and actually we're solving for time, aren't we? So we want T equals D over R. So from that D equals RT, I can just go, okay, T equals D over R. Erase that. Well, what is D? D is 6,000. What's R? R is there, and I just have T equals 6,000 over 300. Boom, done. 20. Just simpler. And so, if you guys understand that, you can just end the video now. I'm just briefly going to do the algebra that allows you to manipulate this equation. So, D equals RT, R equals D over T, and T equals, what does T equal? Do you notice that you can just interchange these right here? This guy goes up here, and this guy goes down here. So it's just D over R. You can just manipulate those. So if I started with the original one that we just talked about, and here's your homework, by the way. In fact, you might not have seen that if I just minimized. If I started with, what was it? R equals D over T, and you're solving for T. We just did it. Multiply both sides by T. Those cancel. T times R equals D. You're just plugging in two things for D. And same thing. If I have R equals D over T, and I'm solving for T, or I'm solving for D, well then what would I do? Same thing. It's just algebra. We're just manipulating the same equation. Remember, division undoes multiplication, multiplication undoes division. So we can manipulate this equation. That just makes it easier. We just allows us to skip one step. Okay, that's all. This has been too long. Okay. And